Okay, good morning class. So today we're looking at the exponential and log functions. I'm not going to try and say the word anymore. Just remember, it is what? Logarithmic. No? Right. People, let's go with us here. We're looking at exercise, examples for exercise 2. The examples for exercise 2 is on page 51. Okay. So let's go. So here we are told that logs and log functions, the definition of logarithms. So log of A, log of X, this is how we say this, no? I think we dealt with logs before. Have we dealt with logs before? Yes, when we calculated in finance, no? Financial maths. So log of X base A is equal to Y if and only if, this is the condition that needs to be met, X is equal to A to the Y. So logs works in relation with the exponential laws. Okay, log is just another way of representing something in exponential function with exponential ways, basically, where X is greater than 0 and A is greater than 0. People, this number here must be greater than 0, and that X must also be greater than 0, which means to say it must be positive. With that said, A here, which is this base here, can never be 1. Why? Because if you look at this here, if you see that number is always greater than 0, not so, but that is never equal to 1. Why? So then it won't be exponential. Okay. And then whatever happens here, that number is always positive. So special logarithm of the log values is log of 1 with whatever the base is, provided that it's conditioned with this here. It follows that restriction, then you will see that A to the 0 is equal to 1. So just something to note at this point is that if A to the X is equal to Y, then if I change this from exponential to log form, then that is going to be X is equal to log Y base A. And if you look at your lines in your book, that's how we write it. Okay, these are your lines in your book. Then we write the log Y base A. Okay, so that is your X. Okay, because if you write X is equal to log, these are your lines, no? Log Y over log is equal to, if these are your lines, and you write it as log A to the Y, that means something different to that thing. Can you see that, people? So this must be written a bit lower, because that is your base. If you write no base here, then that base is going to be 10. Okay, I'm just going to pause the video. I don't want the lesson to be so long. The full lesson can be found in the description box below. Alright, so those are the laws. We say the log of the product is equal to the sum of the logs, log of the quotient is equal to the difference of the logs. If you've got log A base B to the exponent B, we see that P can be written forward as P log A base B. Log A base B can be written as log A base C, a different base. Any base. And the base we normally choose is 10 years. Okay. So it's going to be log A base C over log B base C. But if you make this 5, then this will be 5. Okay, but normally, as I said, we're going to choose 10. And then those are the examples there pertaining those logs there. Note, you will not be examined on manipulation involved in log laws, but it's useful to understand logs. To understand logs better, we exposed you to that there. You'll see it's basic things in logs that we actually do. Okay, so it's not something complex that you're dealing with. But as I explained to you earlier, when it comes to, for those of you studying maths next year, definitely logs is a section that you will have a look at. Okay, people will be looking at the example on page 51. Alright, so with that said, use the definitions of logs to convert logs to exponential form and exponential to log form. Okay. So number 1. Write the equation in exponential form and solve for x. So what did we say? Where will this 2 go? Onto the x. So in other words, that would simply be x squared is equal to 81. So let's solve for x. How do we get rid of the square? We must introduce square root. What must I not forget? Plus minus. So x is equal to 9. Why can't it be plus and minus? Because from the definition we know that this must be positive. So x must be greater than 0. Okay. We don't have to put this here. Okay. Let's look at 1.2. 1.2 says you have log x base 5 is equal to negative 2. So what's going to happen here? It's going to go on to the 5. So therefore, x is equal to 5 to the negative 2. And 5 to the negative 2 is 1 over 20. Is there any confusion there, people? Okay, what are you confused about? Who said yes? Oh no, okay. Hearing things. Alright. People, let's look at 1.3. 1.3 again. We have x squared plus 2x base 2 is equal to 3. Okay. So let's write this in exponential form. Why do we convert it to exponential? Because we are more familiar with exponents. Okay. So what we do is we write that onto the 2. So in other words, x squared plus 2x is equal to 2 cubed, which is 8. Bring that over. So it becomes x squared plus 2x is equal minus 8 is equal to 0. So that's a trinomial to us now. Not so. So what do? Factorize. So we go x and x, 4 and 2, plus and minus. So x is equal to negative 4 or x is equal to 2. And we can test it. Remember, people, this number must be positive. It can be 0. Log of 0 is 1. So let's check. So this is just a check. Huh? So I'm checking for x is equal to minus 4 first. So we got log minus 4 squared, which is 16, plus 2 times minus 4, which is 8. And 8 base 2 is the same as log 2 base 2 to the 3. What's going to happen to the 3? For what? Not so? So it's going to be 3 log 2 base 2, which is 1. So the answer is 3. So that one works. Not so? Let's check the other one. Am I moving too fast here? No? Okay, nice. You check the other one. Do we have to check it like I'm doing here? No, you just punch in your calculator. So let's punch in the calculator. We go here, you got the little log button. You can see here? And here you think that these buttons are necessary on your calculator. No? She says yes, it's not. There are 2 logs there. People, what's the base on this log here? What's the base here? 10. See? 10. So what is log 10 base 10? Okay. Wow. But you see here, there is a log variable, base variable. Right, so let's check. So it's going to be base 2, and it's going to be, I'm testing for 2. So 2 squared plus 2 times 2. So both works. Right, I think in the textbook they are omitting one solution. Just check there. I think in the textbook they are omitting one, if I'm not mistaken. Just check, somebody check for us, please. Sorry? Just check in the textbook. Page 51. Or are they considering both?
No, they omitted the negative form.
But it can be negative form. I'll just show you it can. Yeah? So for those of you who go for help elsewhere, just ask them why is the negative form omitted. Okay. Maybe they know why, and you let us know why, then we will learn in the process. Okay. But according to my checking, it works. Okay. Do you guys understand?
Yes.
Alright, let's go on. We carry on with our lives. Number 2. It says right, but we have an inverse doctor here, isn't it? The girl that's done it before.
It's not for another chance.
Today?
It's not for a chance as well.
Oh. People write the following equations in log and solve for x, correct to 2 decimal places. So what do we do here? So if we write this in log form, what would this be? The base will be 5. So it's going to be, that's going to be your subject. So x is equal to log base 5, 100. So what do I do? Calculator. Log base 5 of 100. Going to be 2 comma 86. 2 comma 86. Okay. You guys understand? Let's look at 1.2. The sum of each 25 is equal to 10 times 1.5 to the x. So what do I do first? I'm going to get this on its own first. I'm going to get it first in the form of a to the x equal to y. That's the first thing I'm going to do. And how do I do that? Divide both sides by 10. So 25 divided by 10 is 2.5 is equal to 1.5 to the x. So now, therefore, x is equal to log 2.5 base 1.5. Put that in the calculator. Log base 1.5 of 2.5. 2 comma 26. Easy, no? Let's look at the next question. 1.3. Is that the last of this before the exercise? Well, homework is going to be exercise 2, the odd numbers. Okay. Now do that in tomorrow's video as well. Tomorrow's lesson. So with 2.3, where do we start? I must get it in that form first. Not so. A to the x equals y. So what do I do first? I divide it by 2. So therefore, 3 to the x minus 3 is equal to 6. Can I write 6 as the base of 3? Make some? No. To a rational exponent, of course. So what do we say? We write this now from exponential to log. So what will this be? That will be the subject of the formula, not so? So that will be x minus 3 is equal to log base 3 of 6. Or log 6 base 3. That's how we say it. Okay. Now what? How do we get x on its own? Take the 3 over. So I can do one of two things, people. Either take the 3 over or punch this in the calculator and then add the 3. Whichever you prefer doing. So it's going to be log 6 base 3 plus 3. So that's going to give us, we got log base 3 of 6 plus 3. That's separate to that. Gives us 4,63. Okay. And of course we can test it. Alright? So what I do is, whenever I see an x, I replace it with 4,63. So I say 2 times 3 to the exponent. Answer minus 3. Should give an answer of 12. And there we go. People, exercise 2, page 51 for homework for tomorrow. Enjoy the rest of your day. Good morning, class. The full lesson can be found in the description box below.